Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 5.3, Problem 9. This is Section 5.3, Problem 9. It says Alan wants to be able to pay himself $7,500 every month from age 65 to age 90 in order to supplement his pension. How much money does he have to have saved at 12% compounded monthly by the time he's 65 in order to accomplish his goal? That's the first part of the question. And then the second part says, if Alan is 28 years old right now, how much does he have to save every month at 12% compounded monthly to have the money he needs by the time he reaches 65? So he's not 65 yet. He has plenty of time. But by the time he gets to 65, he has to have a pretty good chunk of money saved up to pay himself that $7,500 a month for age 65 to age 90. So the first part of the question is a present value of an annuity. He's paying his salaries to himself, but by having the money saved up and it earns interest while it's sitting in an account, a good chunk of that $7,500 is going to come from the interest that it's earned as opposed to the money he puts in, especially near the beginning. So we're going to start with the present value of an annuity formula, which is A equals P times some fairly big brackets. It is 1 minus 1 over, in parentheses, 1 plus R over M, close the parentheses, to the M times T power, and then in the denominator of the brackets, R over M. Now we'll fill that formula in. So we'll have A equals P, the regular payment. So for this particular problem, that regular payment is $7,500. Times, in the brackets, in the numerator of the brackets, the 1 minus 1 over, in parentheses, 1 plus R over M. R is the rate as a decimal. The rate for this problem is 12%, and as a decimal, 12%, it would be written 0.12 over M. M is the number of times compounded per year and the number of payments made. So it's monthly. We're doing 75 every month, and it's 12% compounded monthly. So the M is 12. I'll close the parentheses. The exponent on the parentheses, M times T. Again, M is the type of compounding and the number of payments made per year. So that's 12 times T. Now, it doesn't come right out and tell you the T. We're going from age 65 to age 90. So from 65 to 90 would be 25 years. So M times T is 12 times 25. And then in the denominator of the brackets, we have R over M. Again, R, the rate as a decimal, is 0.12. M, the type of compounding and number of payments made per year. M is 12. So now the formula is filled in. Now I have to start doing some of the computation. I have to start with the parentheses. So that's going to give me A equals 7,500 times the brackets. In the numerator of the brackets, I'm going to have 1 minus 1 over. Now, the 1 plus R over M, the R over M is 0.12 over 12, which is 0.01. Again, the calculator will do that for you if you don't feel that you're really sure about what the answer is. Just enter the top 0.12, divide by the bottom 12 equals. The calculator will tell you it's 0.01. Remember that you're going to add a 1 plus to that 0.01. So in my parentheses, I have 1.01. I'll close up the parentheses. Now the exponent should be 300. Let me just verify the 12 times 25 is indeed 300. And in the denominator of the brackets, the 0.12 over 12 is 0.01. And as I like to point out a lot, the decimal in the denominator and numerator of those brackets, it's the same decimal, but in the numerator it has a 1 in front, in the denominator it does not. Now to make a little more progress, I have to do the 1.01 to the 300th power. So as I write the formula now, I'm going to have A equals 7,500 times, In the brackets and numerator, I'll have 1 minus 1 over whatever I get for 1.01 to the 300th power. So my calculator tells me fairly quickly that that answer is 19.78846626. And in the denominator of the brackets, I still have 0.01. So now in the numerator of my brackets, I have 1 minus a fraction, the fraction being 1 over 19.78846626. So let me do that division out. Again, to do the division, I'm going to press the 1 over x button on my calculator. You can do it a variety of ways. I think the 1 over x button is the easiest way to go. So A equals 7,500 times the brackets. In the numerator of the brackets, I have 1 minus. And when I divide 1 divided by 19.78846626, I get 0.050534487. And in the denominator of the brackets, 0.01 still. So in the top of the brackets, I have to do a subtraction, 1 minus 0.050534487. And when I do that, I'm going to have A equals 7,500 times the brackets. And in the numerator of the brackets, I'll have 0.9494655512. And in the denominator of the brackets, 0.01. So I can divide out the values in the brackets, 0.9494655512 divided by 0.01. That's just going to slide the decimal in the 94 over 2 spots. So I have A equals 7,500 times in brackets, and I'll just sketch it up on my calculator, 94.9465512.5. Close the brackets. And the 94 point something is on the screen of my calculator now. I'll just multiply times the 7,500 in front of the brackets. And the calculator tells me the answer is 712099.1344. So again, I don't want that many digits after the decimal in my final answer, so I want to round to 2 places. So that 0.134 something is just going to chop at 0.13. So the answer to the first part of the question is, the person in this question, Alan, has to have a little over $700,000 saved up by the time he retires if he wants to be able to pay himself $7,500 every month for what he's probably estimating will be the rest of his life, $712,099.13. So regardless of what age he is now, by the time he gets to age 65, he has to have the $712,099.13, and he'll be able to pay himself that addition to whatever his pension might be. But now the thing is, he's 28, so he has a lot of time to get to that $712,000. What does he have to save every month in the same account, 12% compounded monthly, to reach his $712,099.13 goal to be able to pay himself that salary? So this is a whole nother finance question. So what happens? Alan knows his goal. He knows how much time he has to reach it. He knows the amount of interest he can earn. This is a sinking fund because you know the goal. So part 2 is a sinking fund question. I'll even write sinking fund. And the sinking fund formula is P, the regular payment, equals A, the amount that's your goal, over the smaller of the brackets, which is 1 plus R over M to the M times T minus 1 in the numerator of the brackets over R over M in the denominator of the brackets. So for the information for this problem, to fill this out, P would be A, the goal, which is $712,099.13, over, in the brackets, in the numerator of the brackets, you would have 1 plus r over m. So again, r, the rate as a decimal, we're working with 12% as a decimal. 12% is written 0.12. Over m, we're doing monthly compounding. So monthly compounding gives me m is 12. And now the exponent m times t. So m is 12. And now t is the number of years from age 28, Alan's age now, to age 65, the age he'd be when he wants to start drawing the money out. So from age 28 to 65, if I'm doing my math right, is 37 years. Let me just double check. It is 37. And after the parentheses, don't forget there is a -1 as part of the formula. In the denominator of the brackets, I have r over m again. So 0.12 for the r, the rate as a decimal, and m, 12 for the monthly compounding. So let's start computing the work in the parentheses. So I'm going to have P equals $712,099.13 on top of the formula. And then in the brackets, in the numerator, I'll have the 0.12 over 12, again, is 0.01, just like it was earlier in the problem. I'm going to add 1 to it. So in parentheses, I would have 1.01, close the parentheses. The exponent 12 times 37, I think, is 444. And again, I'll verify that real quick with the calculator. And it is. 444 is my exponent. Then and that comes from 12 times 37. I have -1 after the parentheses. In the denominator of my brackets, the 0.12 over 12 gives me a 0.01, again with no 1 in front. There's a 1 in front in the top of the brackets, no 1 in front in the bottom of the brackets. So now I have to figure out 1.01 to the 444th power. And the rest of it will stay for the time being. So I have P equals $712,099.13 over the brackets. Then in the brackets, I have 1.01 to the 444th power equals 82.92585529. There's a -1 after that. Don't forget that. That'll make a difference. And then 0.01 underneath. So the -1 is easy. It's going to become 81.92585529. So that gives me P equals $712,099, and it was 13 cents. And then I have some brackets below that. In the numerator of the brackets, I will have 81.92585529, and in the denominator of the brackets, 0.01. So now in the brackets, I'm going to divide 81.92585529 divided by 0.01, which is just going to be the same number. It's going to slide the decimal over for the 81.92 become 8192.58 something. So that's going to give me P equals $712,099.13 over 8,192.585529. So to finish the problem off, I'm going to divide $712,099.13 divided by 8,192.585529, and that'll finish it off. And it comes out to P equals 86.91995066. So again, in terms of money, I don't need to go more than 2 places after the decimal. So the 0.919 something is going to make it 0.92. So it comes to an almost unbelievably low value of $86.92. So if starting at age 28, Alan saves $86.92, every month until he retires at age 65, he'll be able to pay himself $7,500 a month until he's 90. So that's impressive, but again, it's because of the interest.